Hello everybody, I'm Brent Pierce, and today I will be explaining the fuel system in the aircraft that I train in, and that is the Archer PA-28 with 181 horsepower. I made a reference diagram to explain it as well. So, starting out, you have the right tank and the left tank. That's where the fuel is stored, in the wings, in the right and left wing of the aircraft for this model. And then starting out at your lowest point, you have your fuel straining valves. So this aircraft is engineered to have a low spot in the fuel tank. That is because any sediments, impurities, water is going to settle at the lowest point. And you want to know if it's in there, so it's engineered to be the lowest point, which is typically closer to the fuselage of the airplane. So when you strain it, if there is any sort of impurity, water, etc. in there, it'll come out right at that point because it's at the lowest point of the fuel tank system. So also too, it serves as a safety feature. The valves to grab the fuel and send it up to the carburetor sit up approximately a gallon higher than the rest of the fuel, so there's always going to be 1 gallon of unusable fuel. So if let's say there's like maybe some floating sediments in there or something and you haven't strained it out, it's not going to want to suck that out. It's always going to settle below that, so that adds another safety feature to the fuel system. Moving up from the tanks to the center part, you have the fuel selector. So that's actually in the airplane. That's sitting above the tanks right there to your left, and that allows you to choose the right or left tank to pull the fuel out of. Serves as a safety feature, and also too, when you're flying, let's say every half an hour approximately, you want to switch that tank. So one tank isn't getting lighter, causing the other tank with full fuel to get heavier, causing uncoordinated flight. Safety feature too, because if you have an engine failure, that's one of the steps that you can do to maybe check to see what is it. Because if one of those valves for grabbing the fuel was plugged, you can switch it, crank, and it grabs the healthy valve that's free and clear of any sort of debris and is able to fire the engine back up again. Above that, another safety feature, you have the strainer. There shouldn't really be any sort of impurities in there because of the engineering of the system itself, what I just explained with the low part and the valve sitting above that lowest part, but it's there for another added safety feature. To the left, then you have the primer. The primer allows you to pump extra fuel into the carburetor for engine startup on cold days per se. Always follow the specified POH for that aircraft, because for the Archer, that is 6 pumps on cold startup days. Moving up from there, you have the engine-driven fuel pump. Just as it says, engine-driven. So as that propeller is spinning, it's spinning like a little crankshaft, allowing that to always operate and pull fuel through the system to the carburetor. Look at that, another added safety feature, electric fuel pump. So if that one fails, you have that guy to supply fuel to the carburetor. Also too, another safety feature, because you're always going to have that on takeoffs and landings to add extra boost to the carburetor itself. Whenever you're doing steep banks or maneuvers as such, you're also going to have it on too to add an extra boost and to make it so the engine-driven fuel pump isn't being overstressed. Above that, you have the carburetor. Now that is the device that feeds the fuel into the engine for internal combustion and makes your plane fly and propeller spin. Attached to that, you have the throttle and mixture, which you all should know very well by now. That's in the center cockpit, and it's connected to cables to operate a flap. The throttle opens the flap in the inside of the carburetor to allow more air to come in, which increases your RPMs and causes the propeller to spin faster. The mixture is for how much fuel you want per how much air you're in. So what I mean by that is, the higher you are, the less dense the air is. the further away the air molecules are to each other. So you want to lean that mixture down so you have the right fuel to air mixture while flying. You can, if you're not equipped with the with a gauge inside the cockpit to tell you what to have it set as, you can also listen to the engine RPMs as well. So this is the fuel system for the Archer in a nutshell, and thank you so much for watching, and I hope you enjoyed it.